Okay. Okay. I think it's live. Okay. So. Yeah, that's on. Okay. 2,000 subscribers. And it only took like 4 months. Good day, sir. Congrats for the 2K subs. Thank you, Chemistry Luca. Yeah, it took much shorter period of time to reach 2K than it took to reach 1K. And hopefully that becomes a recurring trend. So this live stream is basically, I guess, a continuation of a Q&A if it wants to be that. But I also figured I have a lot of old videos that some might consider shitty. And I would consider them shitty. Some of my first videos, I had no clue how to use the editing software. And I was just kind of throwing stuff together. So I figured I could watch over some of those while streaming it. And then I also have a channel that I made before I made DBX Labs. And I figured we could check out the one video that I have on there. I actually also have another channel besides that one, but I don't think we'll be looking at that one today. That's a little unrelated. If you have questions, feel free to put them in the chat. I know the stream just started, so people probably haven't gotten the notification, but I got the cat to be on the bed. Last time she was trying to escape the room. Okay. Okay. So one thing is shit. I've been making these chlorine resin ampoules, and I currently have 7 in my possession. Actually 8. But they work out pretty well. Each has about a gram of liquid chlorine inside of them. The pressure inside of the ampoule is around 7 atmospheres, which is pretty good for an ampoule, a borosilicate ampoule. These are just, I mentioned it on the previous video, but the ampoules that I use for these are 13 millimeter diameter, outer diameter, and 10 millimeter, 100 millimeter long borosilicate ampoules, or test tubes, and I turn them into ampoules, and they work pretty well. They hold up to 15 atmospheres inside of them. And then I can put them inside of the resin, and seals up quite nicely, reinforces the ampoule, makes sure it doesn't shatter. These bounce when they hit the ground. They don't shatter. I've hit them with a hammer before. Most I've been able to get is it to chip off, but it doesn't shatter like glass. So they're very safe. Backyard Science 2000 and I are looking into the process of selling them. So stay tuned for that, because that might be an extra source of revenue for myself. And of course, all that revenue goes to DBX Labs. So, okay, comments. Good day. Oh, I already read that. Hello, Backyard Science 2000. I was just talking about you. Nathan L. Hello. Hello. Great channel. I have some things to share with you soon. Laser Steve. Laser Steve. What things? What things? Do tell. Sold. Pricing. Oh. So, frankly, they if you have the means to make one, it would be cheaper that way. But we would be selling them for these ones have some bubbles in them because I haven't yet acquired a vacuum pump to pull the bubbles out of the resin. So these ones I'm looking to sell for around $80. And if you go online and you look at the ones that are currently being sold by, I believe it's called Luciteria or some company like that, they sell it like over $200 for an ampule encased in resin, and it's around 1 gram. All of these are over 1 gram of chlorine, guaranteed. So that's what the pricing looks like. I'm gonna have to see where we go with that. Ampulize some fluorine next, and we'll definitely buy some. No, I don't think I'm gonna end up doing that. Fluorine chemistry is something that I don't plan to go into, at least not yet. That's something I'll put on hold. New routes to aminoguanidine. That's what you're talking about. Well, interesting. Reveal them, because I'm happy to hear some new routes to aminoguanidine. That synthesis, the nitroguanidine to aminoguanidine synthesis, it took so much of my time up. I was doing that partially for a school research project, and in conducting the 20 plus trials and having zero clear successes or zero high yields anywhere close to what the paper said, that was pretty annoying. Pressure instead of vacuum. I don't follow you there. These, in order to have chlorine in them, you have to have a high pressure. And you have to have the vapor pressure of chlorine. It's all determined by the vapor pressure. So the vapor pressure of chlorine is approximately 6.5 atmospheres at room temp. And that basically means that in order for it to stay a liquid, you have to have, well, at room temp, that means that the pressure, the molecules in the liquid chlorine, the Cl2, exerts upwards on the surface of the chlorine is approximately 6.5 atmospheres. So in order to keep it a liquid, you have to counter that pressure with 6.5 atmospheres. And that's what happens inside of these. You have some of it become a gas, and that gas is compressed, and that is compressed to 6.5 atmospheres. And at that point, it forces it to stay a liquid because it pushes down on the chlorine as hard as the chlorine pushes up, or the liquid chlorine pushes up. I'm not sure if that's what you're saying. The vacuum is to eliminate the bubbles. It basically eliminates the pressure inside of the resin and the small microscopic bubbles that cloud these up. become much larger because of the reduced pressure, and they have very low density. So you just create a vacuum and they rise to the surface. Then you reduce the vacuum and they're not there anymore. Hello this evening. Let's get the rest of the basics worked out on posting those for sale. We need to start getting you more income for the channel. Yes. Well, speaking of which, I've already started buying stuff. I bought a bunch of bubble wrap. Back there, I got some envelope packaging to send stuff off in. Yeah, fluorine is a bad idea. Mine is fast and eliminates ammonia fumes. That's another one I'd like to ampule. Ammonia, liquid ammonia. I could probably do that pretty easily with dry ice. Dry ice is kind of my new go-to fun chemical. I realize there's a store like 15 minutes away from me that sells it in bulk, and I'll go and buy it for like $1 a pound. Speaking of which, current project is dinitramides, which require very, very cold temperatures, minus 40 Celsius, as well as limited lighting to produce. And I'm working on that synthesis. I did the first trial a couple nights ago and used about 5 pounds of dry ice to just get that to work. Another 5 pounds went to making these, like you saw in the last video. But I got to evaporate a whole bunch of water at reduced pressure in order to figure out if I actually successfully made the dinitramides yet. So once again, I'm waiting on a vacuum pump for that. It is a lot of bubble wrap. Yeah, they cost like $20. Can't have too much, yeah, if I ever have too much, it's bubble wrap. I can just pop it when I'm bored. Hard to get bored if you have a lot of bubble wrap to pop. That's something you would kind of want on like a desert island scenario. I also have the bromine ampule. This one's a little bit more fun because when you shake it, you can feel the mass to it, and you are yeah, it looks cool. If it looks cool, it's a nice table piece. Oh gosh, the chair is popping bubble wrap. Dinitramides are really neat, but damn, things need to be cold. They need to be cold when you make them, but once you neutralize them, dinitramide acid, I believe that's what it's called, it's very unstable in acidic conditions, even at low temperatures. So as soon as it's made, you have to basically neutralize it, keeping it at the very low temperatures. But the neutralization process, because you're producing it in a mixture of nitrating and, nitric and sulfuric acid, the problem becomes that you're adding, in my case, potassium hydroxide to an acidic environment, very acidic environment, and hoping that it doesn't go above 0 degrees Celsius. Because the neutralizing step has to be done at below 0 degrees in water, which is hard. So that I think I had some problems on the first synthesis. I kind of know what I'm going to do to work around that next time. Another thing that I'm currently working on is editing the video on sodium nitrotetrazolate 2N oxide. I already made it, and now I just have to record some testing. I was talking to Explosions and Fire about that a few days ago. I still got to send him some information about that, how it worked. Am I interested only in energetic compounds? Trying to read the next comment. So, no, I mean, clearly I enjoy doing other sorts of chemistry, but energetic compounds they pique my interest because they're explosive, and that always has a ring to it. It's, wouldn't say fun to play with, but fun to research because there's a energetic aspect to it. It's especially primaries, because you can see the detonation on a small scale. You don't have to take it to a very large kilogram amount to get a good sense of the explosive properties, like silver nitrotetrazolate. Its DDT is just astronomically small, so you can see the tiniest amounts detonate and fully detonate. So that's pretty interesting. Dinitrogen trioxide in an ampule would be a nice conversation piece. I actually did that, but it was before I was good at making ampules, I would say. So yeah, I did that, but it all the ampules were not properly made, and they ended up popping before I could get anywhere close to sealing them. So I think I'll do that next time I buy some dry ice. I have some nitric acid on hand that I can make some nitrogen dioxide with. Pump that into the super cool environment. That's how I did it last time. It has a nice blue color to it when it condenses the dinitrogen trioxide. When placed under pressure, any air bubbles entrapped shrink to the point where they are no longer visible, 60, 80 psi. Well, I'm sure that does work. I'm sure it does. Alternatively, making a vacuum also works, because you basically pull the bubbles out, and then when you return it to atmospheric pressure, any bubbles that didn't pop already are once again greatly compressed by the atmosphere to an even smaller extent. It's a lot harder for me to compress something to 5 times atmospheric pressure than to pull off 1 atmospheric pressure with a vacuum. So I'm sure that could work, but it's more difficult for me. But yeah, Laser Steve's idea of dinitrogen trioxide in the ampule, I'll work towards that. Gotta get more dry ice before I can do that. But what else? Okay. Oh, modified pressure cooker and dry ice. I'm sure that is cheaper, but when you put the words modified pressure cooker out there, that worries me a little bit. I don't know how comfortable I would be around a modified pressure cooker with dry ice in it. I might have to agree with Backyard Science 2000 on that. Love from India. Thank you. You can send money for dry ice. Dry ice is pretty cheap. It's like I said, it's $1 a pound. And I mean, the real concern there is whether Safeway has dry ice the day that I go to get it, because the Safeway that I go to, there's a 50% chance that they have zero, and I'm showing up for no reason. So, yeah, dry ice will be involved in a lot of future videos, and hopefully, I might be able to look towards a potential synthesis of pentazoles this summer. Although the surprisingly, and I guess ironically, the precursor to making the pentazoles is the most expensive aspect. The environment to make them is just dry ice and a cooling bath of sorts. And there's some other complicated steps, but the precursor, I believe it's something like 2,6-dimethyl 4-aminophenol, something like that. And it is expensive. It's like $500 for 100 grams. And I reached out to a bunch of suppliers, and that's pretty much the best that I could find. But if I can find a cheaper source, or if I can acquire a smaller amount, I should be able to attempt a pentazole synthesis to produce sodium pentazolate, which is stable at room temperature. And there's a lot of interesting chemistry that certainly has not been done on YouTube in regards to that. So as reality permits, do you plan on creating plasticized energetic materials in the future, such as then proceeding to ascertain brisance through testing? See, that, yeah, so you say as reality permits, that's not really a foreseeable aspect of reality for me. So, I mean, Explosives Laboratory, you're the one that's saying that of all channels to be testing that sort of stuff, by all means, it would be you guys. I would not be able to get away with putting those, making and putting videos out there on that. I'll leave it at that. Please make video on propellant for RPGs. No, I'm actually working on finalizing the P bucket chemistry that I did probably 10 months ago, and the P bucket has been sitting outside getting sunlight maybe 4 hours a day. The rest of the time it's shaded. It works on the process of nitrogen fixating bacteria that convert urea, or rather ammonia produced from urea, into nitrates, and that's basically the method that was used to produce nitrates for gunpowder way back in the day. My point is, I'm gonna get working on I'm already working on it again. I just have to do a few more things before I can record a video. I probably should add a bit more urine to it, because in total I probably added 50 gallons or so, but to really maximize the yield, I should probably do more. Seeing that you are looking at selling items to generate income, do you plan on selling a set of various fluids? So, I mean, this kind of qualifies as one of those. Same with bromine. However, other hazardous fluids, I'm not really sure where the liability goes for that. These are just things that I already see being sold on eBay, but things like selling dinitrogen trioxide, I'm not sure if I'll sell an ampule of that, even if it's encased in resin. However, I personally am looking at, once I get something to pull a vacuum, make a really, really nice ampule of mercury that's cleaned and everything, and seal that in resin, so it's a nice table piece, and mercury right there. That'd be somewhat cool. Yeah, various fluids is a little vague. I'm not sure exactly what you're suggesting there. I just took it as, I guess, dinitrogen trioxide. Okay. So we're like, how many minutes in? Like 30 minutes in. I think we'll watch my first video, or I don't know about my first video. That was really long, and half of it was completely unnecessary. So, thank you, Ubad's Lab. Thank you. We'll see what videos I can watch from my earlier days. So yeah, I got monetized. That was a big deal. I didn't know if I was going to get monetized or not, or if upon review for monetization they would treat the channel as if it was a science channel. But I guess they didn't, because I got monetized. So that's pretty cool. So far AdSense says that I've gotten $10.44 over the past month or so, which is far better than I thought the channel would perform in terms of monetization. But we'll see how that goes. I'm still working on setting up the AdSense, because there was some technical difficulties of sorts that I was trying to work out with YouTube. Okay. Any plans on doing electronic projects? Well, there's one in particular that I've been looking at for a while, and that's making a Wimshurst machine out of CNC parts. And that would be something in junction with Carbon Coil, since he has the CNC router. But it would be a cool project. I mean, if you're not familiar with a Wimshurst machine, it's basically it can be hand cranked or motorized wheel, or two opposing wheels that spin in opposite directions, and through the triple electric effect, just like sort of like a Van de Graaff generator, it produces extremely high voltages, and typically the voltages are stored in a pair of Leyden jars, and the Leyden jars are close enough that they have two things that stick out, two electrodes, and you'll see the arc go across. How can you donate money today? I believe I set up a what's it called? There's like a, I forget what it's called. There's some like option next to the emoji, in the create a comment. It's like a dollar bill. That's one option, I guess. So that's one plan for electronic projects. Another plan for electronic projects is a lightning rocket that I've been working on that project for probably 2 years now, maybe 3. The problem is filament is extremely hard to get that is sturdy enough where a pound of tension doesn't break it, but also light enough that I can get a SDC engine model rocket and shoot it up in the air, and it carries 2,000 feet of coil. So that's something I'm looking at. Hopefully I could get something working this summer. That'd be pretty cool. Triple distilled mercury ampule cubes. I'm not distilling mercury. I don't know where you're going with that. But like a gram mercury ampule in a resin cube, that's something that I might have as a personal table piece or something. Probably more than a gram. A gram is like one of those tilt switches that you can buy for $20. Work beckons, must go. Congrats on 2,000 subs. Stepping stone. If you need help setting up a site, just ask later. Okay. What kind of site do you mean? I'm not really sure I follow you on there. Patreon. The Patreon, I believe it's just patreon.com/DBX Labs, I think. Just look up DBX Labs Patreon. Super Chat on the right. Yeah, that's what it's called. Super Chat, and it's somewhere in the comment area. But I have to go for now. I have 15 orders to get ready from orders from last night. I'll give you a shout this evening. Talk more about the cubes. Thank you, Backyard Science 2000. I'll talk to you about that later. I'm rapidly getting supplies to sell the stuff, but I still haven't gotten the boxes yet. Yeah, you distill white phosphorus regularly. I've done that synthesis 3 times, and every time it scares me. It's tedious and scary synthesis. Thank you, Explosives Laboratory. You don't have to do that. You already are a patron for that. But thank you. This is an example of a super chat. A small portion of revenue goes to YouTube, but the majority goes to DBX Labs, so consider donation via Patreon and you'll receive more currency at the end of the day. Thank you. Can you use PayPal? Yeah, there's you mean PayPal like directly to me. I'll have to see what I can do there. I currently don't have like a direct PayPal for that, but I'll look into it. Congrats on 2,000. Keep making good videos. Thank you. I'll do my best for that. Great job on 2K subs. Really enjoy your channel and keep up great work. Cool projects. Will do. I figure I should look at some of the projects that I'm looking into. So I put a lot of them on the beginning of the last video. Before it started, I put a lot of the future projects. And so, yeah, a couple of them are ripening fruit with acetylene. I work on a pick your own fruit farm, so it's very accessible for me to get dude, thank you for thank you, Laser Steve. That's very helpful. Thank you, Backyard Science. Thank you. Yes, awesome, Laser Steve. That's very epic. Very epic indeed. Very epic indeed. Thank you. Thank you. Well, continuing on what I was saying. The ripening fruit with acetylene, that it's a fairly easy process. Basically, you put unripe fruit in an environment of acetylene gas or ethene gas, which is just ethylene, but they do the same thing. I believe acetylene actually does it a little bit better since they use it on the industrial scale for some stuff. But it's a pheromone for the fruit, and the pheromone causes the fruit to ripen faster, I guess. It's produced by the fruit on their own. Like if you take a bunch of fruit and put them in a bag together, the pheromone of ethylene that's produced causes the fruit around it to ripen. It's biochemistry. I don't know much about it, but it'd be a cool video to do. Another one is the pea bucket, which I already talked about. DBX1, I want to make a new video on that, because that was a video that was pretty unexplained. Well, I didn't go very in depth on that. So I'd like to make another video and explain some of the properties, especially considering that last time I made a video, I was using a vitamin C tablet to do the synthesis. But this time I have a bunch of ascorbic acid, so it'll be a lot more effective. I've actually done the synthesis many times since I made that video, and it should work a lot better because I got all the problems worked out. Explosives Laboratory, thank you, as are you, and you're welcome. DBX Labs anytime. Have a great day. Thank you, Backyard Science, and I'll talk to you later. Once again, thank you, Laser Steve. That's very helpful. That will go. Let's see, what can that go directly towards? Well, I know. I just spent $100 precisely on a vacuum chamber, and that can be used for a bunch of different things, like pulling water out of solutions that have to be kept at, say, below 50 degrees Celsius, but I need to evaporate them off, like the dinitramides. It can also be used for the resin. It can also be used for drying stuff. Any fireworks projects? No. It's highly unlikely that there will ever be fireworks projects on DBX Labs, because that it tends to reach outside of the realm of legality, especially for me. For other channels, it's more feasible. Explosives Laboratory. I'd say that. DBX1 is your first choice. Since you're saying that, I will get right to it because I got all the stuff ready. I just haven't started filming, I guess. Some other video ideas. This was just like a short video. I wrote it down. A lot of these I write down after thinking of them. Get out of bed and think of them. Or think of them, get out of bed and write them down. Burning a candle in pure oxygen. I have a lot of pure oxygen on my hands, and I basically have to exhaust it all before I can refill the tank with argon, which will be used to distill cesium in the future. So one way to expend some of the pure oxygen is to put a candle in it, light the candle, and basically see what happens. I thought that'd be pretty cool. Silane plus pure oxygen. I kind of wanted to see if I could collect silane gas without it spontaneously combusting. It's an explosive gas, so that'd be. I'm still not entirely sure if I'm going to tackle that because it seems a little bit sketchy. Another project. This will be a lot more difficult. I've already looked into some ways that I can do it, and they all seem not expensive, but tedious, to say the least. Making a ring out of cesium, like cesium metal inside of a resin ring. And I can imagine a lot of things would go wrong in trials of making that. But if I can distill cesium, I should be able to make several trials. Other video, aminotetrazole nitrate and aminotetrazole dinitramide. They both have energetic properties. Aminotetrazole nitrate is actually used as a monopropellant. So that's pretty cool. I can also send you some boronol. Boronol. Is it Borneol? I'm not sure if it's boronol or borneol, but low temperature sodium video you have mentioned. Yeah, I have worked for the past month or so on a sodium video. It's actually the high temperature sodium synthesis with dioxane. You basically react magnesium metal, which I have an extreme abundance of, with sodium hydroxide in the right ratio, and it yields sodium metal. You take the aggregate, the forms, and you put it in dioxane and reflux it, or distill off the dioxane, and you're left with some sodium. And I've done it with successes, but I haven't done it with enough trials to make a video off of it. So I'll work on that. I take it that with the borneol or boronol, that's with the alcohol catalyzed reduction of sodium hydroxide with magnesium. If that's the case, I can certainly try it again. That was probably the first big project that I ever did in terms of chemistry, was going about Nerd Rage's method of producing sodium with menthol as an alcohol catalyst. And it never worked for me. I would see tiny little spheres of sodium metal, but I would never, ever get a consolidated chunk of sodium like he had in his video at the end. And that, I probably spent $400 on that synthesis over the course of a half a year. And this was before I had a consistent summer job anywhere. So it was a lot of money I just spent on that attempted synthesis. But I'm sure now I have more experience and I could probably get to work. Okay, so yeah, borneol. I figured it was that. Really love the liquid chlorine video. That was awesome. Keep doing awesome stuff. Yeah, I should mention that Reactive Chem already had a liquid chlorine video, so you should check that out if you liked my liquid chlorine video. He made a few ampoules that way, and he showed the process of testing them in hot water, which is something that I didn't show in my video. One of his actually, or probably several of them, exploded when he put them in the hot water, but I didn't show that process just because it was a short video, not a lot of editing. It's really easy to make those videos with practically zero voiceover. So in the summer when I'm trying to pump out a lot of videos, that's probably one of the ways I'll go about it. Have you ever or are planning to work with energetic polymers adhesives? Well, I have, but I haven't made videos on it. There's a few energetic binder agents that I've tested with in the process of attempting the process of making shaped things for testing, of course. Very much only for testing, and underground testing. I'll especially so, like deep underground, 4 feet to 6 feet deep testing of shaped things underground. I had to use some. I attempted the use of energetic binder agents to get that to work. Just a word of caution. Oh, don't mix TCCA with ammonia or ammonium hydroxide. Bad things can happen. I feel like that would produce chloramines, but I feel like it could also produce nitrogen trichloride. Don't want to become James Campbell. If you're not familiar with the YouTube channel James Campbell, he's a guy that I saw his videos like a year ago, and it just blew me away. He's insane. He makes tremendous amounts of nitrogen trichloride through, I believe, calcium hypochlorite and what else? Maybe it's just ammonia, household ammonia he adds to it. Don't do that. Don't do that. That's not a recipe. That's I'm not suggesting that. That's just how he does it, and exposes it to sunlight, just blows up. Not very safe. I wouldn't recommend that. But yeah, he's insane. And Explosions and Fire, in one of his more recent videos, he actually referenced him in some funnier aspects of his channel. Yeah, he may or may not. I'm leaning towards the he may for that. Yeah, nitrogen trichloride is probably the worst of all yellow chemicals. So, as for the question, have you ever or are planning to work with energetic polymers? I do have an energetic polymer called nitrocellulose that I enjoy making. And that is a polymer. So that's one thing. And I actually haven't made a video on that. So I guess that classifies as a video on that. Okay. So I made a post on this recently, but I have acquired some Venus flytraps, which are very cool, and I actually I could I have a fly ready if you guys want to see a Venus flytrap eat the fly. Although I have to run and go get it for probably 3 minutes and be back. Yeah, good question. You said you were going to make a kilo of that. Yes. Yes, I had a feeling someone would bring that up. Yes, I have worked on doing that for many months now, but making a kilogram of nitrocellulose is very tedious, especially with only 14 liters of sulfuric acid, which is a lot of sulfuric acid. It's like $140 worth of sulfuric acid on its own. And I found out that it's not even enough to nitrate it all to the hexanitrate. So that's something that I'm working on. It's taking much longer than expected. I'm sorry, but it will be done in the future. It will be done. The nitrocellulose. I'm working on it. Right now I have about 350 grams, and I haven't been able to put as much time forth to that as I would like, but it's going to be done in the future. What's with all the message retracted? Only 14 liters, yeah. It's a lot. It's a lot, and most of it is already exhausted in making that 350 grams or so. So it's a long process to make that. Okay, I answered your question, I see, since you gave me the thumbs up. Okay, so should I watch earlier videos or should I feed the Venus flytrap? Because it needs to be fed, and I got a fly ready in a cup, but I haven't fed it yet. I'll leave that question out there, and you guys tell me what to do. If I'm gonna watch a video, it's probably gonna be, I don't know, this one. I remember I put some funky music in that. Feed the plants. I'm on it. Okay, I'm back. So I want to make sure that everything's shown on the camera. Okay. So here's the trap that we'll be feeding. And here's the fly that we'll be feeding to the trap. Okay. I'm going to feed it now. And there it goes. Looks like it picked it up pretty well. And so now it will digest. Okay. Yeah, Venus flytraps are pretty cool. They're probably one of the most specialized plants. Oh, the cat's interested. They're probably one of the most specialized plants that I can think of. The evolution that goes into producing a plant that consumes a living organism such as a bug or small insects or small amphibians. They'll eat salamanders and frogs and stuff. It's complex. They have a really interesting system that actually determines whether it will bite or not. They have to have if a fly lands on the trap, it has to hit not one but two of the inner hairs within 20 seconds of one another. If it doesn't hit both within 20 seconds, then nothing happens. And that's to stop it from misfiring, I guess. But that's one interesting aspect. Let's see. Oh, the video. Okay. I guess now we'll watch the aminotetrazole video. So I stopped using the intro mainly because it was long. So I might consolidate that intro at some point in the future, so I can still throw it in. But it was long and tedious to change for every video.
Episode of DBX Labs, we're gonna make 5-aminotetrazole from aminoguanidine bicarbonate. And the way we're going to do that, I kind of went over in the last video. We're going to do a diazonation with sodium nitrite, followed by a basification. I'm going to use baking soda, and that's how we're going to cyclize the aminoguanidine into the 5-aminotetrazole. Get that tetrazole ring formed, and from there we can make a whole bunch of other compounds. So here's the 4 chemicals that we're going to need for this procedure. Baking soda for the basification, the aminoguanidine bicarbonate, of course.
There's a lot of ums and uhs that I've had to work to get out, and they're very apparent in this video.
Soluble salt and water, that is, and sodium nitrite to do the diazonation. I forgot to mention that
we'll skip around. It's a 20-minute video.
Allows us to diazonate it once we add the sodium nitrite. We then prepare a solution of 21 grams of sodium nitrite and 44 milliliters of distilled water.
That was back when my graduate cylinder
We
still
now
was
prepare a
intact.
cooling bath for our solution. Turn it on high stirring and set up an apparatus to slowly drip the nitrite solution into the aminoguanidine solution, which is now entirely soluble and acidified. We now begin the additions of the nitrate solution into the aminoguanidine solution. These additions should take at least 30 minutes to prevent the release of large quantities of nitrogen oxides. Currently, the temperature in the solution
Right here
is 15
is
degrees Celsius.
my HHO generator that
The
I have not
reaction
fixed yet.
should never go
But
above
that should make a
25
pretty good
degrees
video
Celsius.
if I ever get that back up and running. I can melt copper with it. It produces a
Now
I
that
can
all the
feed it
nitrate
into
solution has
a
been
torch
added, I'm going
that's-
to let the solution
gets
sit, stir,
3,000 degrees Fahrenheit
stir
or
for
higher.
20 minutes at roughly 20 degrees Celsius. It has to warm up a little bit before I start timing it, but after that, it should be basified by the sodium bicarbonate and then refluxed. The tetrazole ring is highly resilient to pH change, and the synthesis still works even if your pH turns out to be shortly. But it looks like pH is still right around where it needs to be, so we'll let it sit. Here's the remaining solution that was filtered off the crystals. With some of the wet product, we can try a contained burn test.
It's not actually as bad as I thought. I haven't watched this video in probably
But I've never gone much more than that to ever.
10 months or so.
Though
It's
that-
been
that
a
is
really
pretty
long time since
considering,
I've seen some of these first videos because I
the
thought they were too
Monetization
cringeworthy to
a
watch.
very beyond burning.
And in for some of them
very
they
low.
are.
It's not.
But this one isn't as bad as I thought.
Chemical. In order.
Okay. It's that's a good video. I guess I'm realizing now that it wasn't that bad. Echo coming through though. Never figure out how to start out with aminoguanidine nitrate instead of bicarbonate. Well, I guess you could just make the bicarbonate and go from there. You do make aminoguanidine nitrate, I believe, by neutralizing the bicarbonate. So that kind of it'd be a little bit redundant to do that to make the bicarbonate from the nitrate, but I feel like that would just be some stoichiometry to figure out. How are the bees? The bees are dead. Yeah, the bees are dead. They died. But next year we'll probably get some more. Yeah, they died over the winter. But it is what it is. Bees die, and you get more bees. Kind of happens especially where I live. Bees aren't really meant to live for a very long time where I live. It's not the best area due to the cycles of when stuff flowers and when it gets cold and all that. It's, you go north, bees do better. You go south, bees do better. So yeah. Okay. So I gotta go at like 1:30. So I think that now I should reveal the channel that I had before DBX Labs, long before. And that was called Simpler Science. Simpler Science. It has one video. I actually had a channel even before this, but that's for another day. We'll watch this.
Find the perfect song for your video in 5 seconds. Go to artlist.io.
Somehow this is advertised.
It will be over here.
And that's all fluorescein.
Today on this channel, I will be demonstrating how to use electrolysis of water to separate hydrogen and oxygen atoms and hopefully to get enough hydrogen gas to fill up this. The first thing that I'm going to do is solder.
Okay, I should mention that this video was released March 4th, 2018, but I filmed it all the previous year. I just compiled it and edited it the days preceding March 4th.
The wire onto the two ends of the battery, also known as the terminal. Since I've connected two batteries, the first end will be over here, the second will be over here. This is the negative and this is the positive. I'll be referring to those later to tell which gas is being released from each of the wires.
I had no clue how to work a soldering iron. I would just drop the liquid solder into it and hope it would stay liquid, which didn't work. It didn't stay in there. I actually, I think somewhere I actually have this original setup, and it just kind of fell apart. The wires didn't stay in the place.
One of the main reasons I used a 9-volt battery is due to the fact that
the bees died.
Both of their terminals are very easy to solder with. In the next step, I will use the soldering iron to puncture 2 holes on either side of the container. The holes just need to be big enough for the wires to go through. Okay, so what I just did was I took the wire that I had soldered onto the batteries and I wrapped it around the batteries to make it a little bit easier to work with. And after I did that, I put the wire through the holes that I made in this container. By the way, this is a tennis ball container. I just found it in the garage, and it's pretty easy to work with. That's something that I would assume most people would find easily accessible. And so then what I did was I took the silicone, and you could also use hot glue for this, but salt, as long as it's NaCl, which is table salt, which is, that's what I'll be using. So, the difference should be pretty clear. Right now, it's already releasing a little bit of hydrogen. I don't know if the video picks that up, but it is releasing a bit of hydrogen. The oxygen being released on the other terminal, the positive terminal, because oxygen is anion,
it is not nearly as drastic. You can see a lot of hydrogen being released, and that'll be a lot more clear in just a moment. So I'm going to pour some in.
Yeah, there are a lot of mistakes in the chemistry in this video.
Just wait for that to calm down a little bit. And
this is like,
I believe,
8th grade.
You can see now the amount of hydrogen being released is much more. Much more. Okay, so when I came back, clearly something has happened. I'm not really sure what the green is, but I know that the yellow at the bottom, that is chlorine. Chlorine oxidizing, and it's yellow. So I found out what I'm going to do. I'm going to use a strong magnet and a nail.
I mean, it was a shit video, but I did succeed in making the hydrogen.
I'm back. It's been about an hour.
That got loud.
But don't want much water in there. So the hydrogen. So yeah, that was definitely, it's more explosive.
First time I worked with explosives on YouTube. That video is. Okay. So now to read the comments. Why are there special clips if you can saw right there? I don't know. There were a lot of mistakes that I made in the process of recording and in making that video, so yeah. Yeah, the soldering to 9 volts is a lot easier than soldering to any other batteries, but it's probably also not the best way to connect to a 9 volt. Yeah, I had no flux then, and I still don't have flux that's from before 1970. Yeah, there's a subtle pain to the awkwardness of the video. Yeah. But that recording of myself is on YouTube, and now I've made it known. So, and like I said, there's another video, but that's for another time. If I ever reach 5,000 subs, then I'll release the way worse cringe video that I have from a long time ago. But yeah, 5,000 subs. If I make it, then I'll release it. Then I'll link it. I think Reactive Chem already knows about it. I'm pretty sure I sent it to Reactive Chem. Okay. Well, I pretty much covered everything. If anyone has any questions, then that's really it. 2,000 subs. I guess it was a live stream, Q&A, and whatever else. I didn't really have much planning going into this, if that wasn't clear enough. I didn't really plan out what we'd be doing here. Is it easy to get chemicals there? It's the United States, which means that iodine and phosphorus are no chemicals, but nitrates are very accessible, and Perchlorates aren't. I wouldn't say they aren't anymore, but it is relatively easy to make perchlorates with an electrolytic cell. So that's kind of, I think that answers the question. It's relatively easy to get chemicals, although they are expensive if they are coming from anywhere outside of like Amazon.com. Like I can buy from Fisher, and I could also buy from Sigma, but they're very expensive. The aminoguanidine bicarbonate that I used in like the first video, or the amino tetrazole video I just showed, that was $70 for 250 grams. I know in Europe it's the opposite, that you can get all the iodine and all the phosphorus that you want, but in the US it's the direct opposite. You can get nitrates at the grocery store, but can't get iodine. Iodine only means one thing if you're in the US, and I won't mention what that means, but I'm sure most of you can infer. ATF licensing. Well, I got a plan laid out that after college I'm gonna find a plot of land out in Utah or Nevada or Wyoming, and there I will get every piece of licensing that I can ever get and have fun. That'll be fun. Do all sorts of testing. But that's for the future. I have to save up money for that. I've got to work out the details. So, okay. That's pretty much it. I think I'll end it. It's been an hour and 20 minutes, and I gotta go buy some Chinese food. So, yeah, for lunch. Oh, a normal 9-volt clip terminal and split it. Yeah, that I actually bought a bunch off AliExpress, and that's what I do whenever I need to do that. Now, I actually think I have. Do I have it over here? Yeah, I bought a bunch of these off AliExpress. AliExpress is such a lifesaver. I bought some 2429 Erlenmeyer 1 liter flasks off AliExpress. They're like $12 a piece, and they might be really shitty, but they do work for a while. Most of the time when I break glassware, it's because it's falling a height of 4 feet. So if really any glassware is going to shatter when it drops 4 feet, I can't really blame Chinese glassware for that, for being not effective enough. Any favorite chemicals? I mean, if I have to pick a chemical that I'm most happy I made, azide was a big video to make. Like that video was my first big project. So I'd have to say that that's my favorite energetic chemical, isocyanogen tetraazide, because it was the biggest accomplishment, I guess. I'm not sure if that's really what it would be, but it was a long project, and it worked out in the end. So, yeah, that's the We will conduct a duplicate of Trinity together. It will be so much fun, dude. I have some Trinitite. All that's slightly related, but yeah, Trinitite from the desert sand that got molten in the Trinity explosion. It's a green glass that's slightly radioactive. Pretty cool. Yeah, ATP is pretty nice. Okay. Well, I think I gotta go get Chinese food now. So, thank you, everyone. Thank you, Explosives Laboratory, for the $20. Laser Steve for the $100. Thank you very, very, very much. Going to good use. And Backyard Science 2000 for the $20. Thank you a ton, and I'll talk to you later. Thank you, everyone. Have a good day, and I'll make some videos in the upcoming weeks and upcoming summer. And adios. Maybe I'll have a 3,000 sub live stream, or maybe I'll wait until like 5,000 or something. But adios.